what happens when you have a nominal target? Okay, if you have nominal target, then you don't have an enforced ordering. So you can't say that, okay, either 0 or 1, and the third one will be 2. Okay, you can have 0 or 1, or 0 or 2, or 1 or 2, and there are all combinations possible. So we have to place one value as a base value, okay, and then compute probabilities for the other two. So here, for our convenience, we will leave 2 out, and we will have models for 0 and model for 1. Okay, so model for 0 we already have. Okay, we just computed here, so we can simply use the same values. Okay, all right, and then your new observation is, we'll use the same observation. Okay, now we have L. L is also the same from here. Okay, now except that we're not going to compute e to the power of minus L now. Okay, so we're going to do exp of L. Okay, not minus L, L. Okay, and we can go through the computations, and we will see how this is going to work in just a minute. Okay, but we have to use e to the power of L. Okay, now this is for apply equal to 0, and then we need another model, apply equal to 1. Okay, just 1. So your model 3 here is if, okay, original, so if apply equal to 1, it is 1. Otherwise 0 for the other two. Okay. Then, okay, now this is for the third model. Now you have to set up the maximum likelihood function and run solver. So L will be, okay, so this is our third model, and these are the cells where we're going to determine B coefficients from solver. So we have B sub 0, C49, we have to absolute reference that, plus some product of these 3 cells, absolute reference that, okay, and these 3 values. Okay, so that's our L. So now we can copy these 4 cells over, and then copy that row to the rest of the rows. Okay, and then sum this column as the set target cell. So that will be our maximum likelihood function, logarithm of maximum likelihood function. So we do the sum of that, okay, and then run solver. So now solver, we need to change the objective cell to that, and the changing cell to these. Okay, so now we have the model 3, apply equal to 1. Again, we do find the e to the power of L. So that will be B sub 0 plus some product of slope coefficients with these 3. so now copy that. So now you have 2e to the power of L. Okay. And now the formula is, okay, so the L here, okay, let's see. So this is the first one, right? So the formula for the denominator, okay, so you should have so e 1 plus e to the power of L1 plus e to the power of L2. So you add these two and then add 1 to it. That goes in the denominator, and then e to the power of L1. So that's your probability of 0. Okay. And probability of 1 is you have the same denominator, and you can, with some algebra, you can derive all this, but I'm not going to go through the derivation. So e to the power of L sub 2. So that would be p sub 0 and then p sub 1, and then the third one will be the difference such that it adds up to 1. Okay, so let's do that. So this will be, okay, e to the L, right, divided by 1 plus that plus that. So again, here it is e to the power of L, not e to the power of minus L. Okay. So that's that, and then take that divided by 1 plus that. The denominator is same for both the situations. So the first one you use the first e to the power of L, second one you use the second one. Okay, so that gives you this, and then you do 1 minus. Okay, you take, no, because the three probabilities need to sum to 1, you subtract those two from 1 and you get the probability.